Okay, so Module 3 is going to be strictly quantitative research designs. So we're going to start off with the first half of Chapter 11, which has to do with validity and quantitative research. And the second half of the chapter has to do with qualitative research, so we're going to get to that in the fourth module. We're not going to cover it this time. So let's start by talking about causality. When we do a quantitative study, we're looking at the relationship between an independent variable and a dependent variable. The study that most quantitative researchers aspire to doing is a causal study, in which we can claim that changes in the independent variable directly produce the corresponding changes in the dependent variable. In order to make this claim, there are three criteria that actually need to be met. The first is we actually need to see a relationship between the two variables. If we're manipulating or changing the independent variable and nothing is going on with the dependent variable, then clearly, there's no relationship there. The IV doesn't do anything to the DV. So it's not possible to claim that it actually causes anything, or the changes in the IV actually cause changes in the DV, because they don't. What we're looking for are systematic variations in the dependent variable when we manipulate the independent variable. And manipulate, like I said, it just means changing the variable. So for example, we might be able to see a relationship between positive advising experiences and student success in college. Secondly, in order to determine causation, we need to also have what's known as temporal precedence. We need to be able to say with certainty that the independent variable occurs in time before the dependent variable. In a lot of what we study in educational research, it can be actually kind of difficult to determine which comes first. We might be able to see this relationship between positive academic advising relationships and student success, but can we actually say that they cause success, or is it that successful students just think more highly of their advisors? So which came first, the positivity or the success? It's hard to tell unless you design a study specifically to address that question. And the third thing that we need in order to determine causation is a lack of plausible alternative explanations. And this is the big one. When we're looking at a relationship between an independent and dependent variable, we want to look at just those variables. So we can say without a doubt that the IV causes something to happen with the DV. In quantitative research, isolating two variables so you can look at their relationship is ridiculously hard to do. It's very difficult. What happens is that all these other variables sort of sneak into the picture and try and complicate things. They create all these alternative explanations for the result of a study, right? These are what are known as extraneous and potentially confounding variables. So what if student success has really nothing to do with academic advising, but is instead explained by parental messages about education? Well, since that wasn't part of our initial study, we can't claim with 100% certainty that parental messages had nothing to do with student success in college. And probably, if you think about it a little bit, those probably do have quite a bit of influence on how successful students are. But a key word in this third point is plausible. Now, I know it's a favorite pastime of graduate students to sit in class and poke holes in quantitative research, coming up with all the different examples that are sort of contrary to whatever has been found by the study. I've done it. Your professors have probably done it, and I'm sure you've done it as well. Pretty much any study that you look at could have some kind of alternative explanation for the results, but not all of the explanations are going to be equally plausible. The alternate explanation of parental messages, that might be more plausible than, say, telepathic aliens from another dimension are beaming the correct answers into the students' minds without them knowing, and that's what made them successful in college. I mean, yeah, I guess that could probably happen, but I don't really think so.
Must be those strangers that come every night, those saucer-shaped lights put people uptight, leave blue-green footprints that glow in the dark. I hope they get home alright. Hey, Mr. Spaceman, won't you please take me along? I won't do anything wrong. Hey, Mr. Spaceman, won't you please take me along for a ride?
So let's talk a little bit about these extraneous and potentially confounding variables. Remember that our earlier definition of validity from the last module was that you're actually measuring what it is that you claim to be measuring. So quantitative researchers go to great lengths to demonstrate that their research is valid. And the real world it's very complex, right? There's a lot of interactions between a lot of different variables happening all the time. And in order to just isolate a couple of variables, we need to be able to control for the others. So this means either to eliminate them completely from the study, or to try to hold them constant as much as possible so they're not changing. However, because of the natural variance between people and our high susceptibility to contextual influences on our behavior, it's very difficult to account for every possible variable in a study that could influence the results. In practice, the researcher needs to be able to differentiate what might be a plausible and implausible alternate explanation. Which variables might significantly distort the results, which are just probably harmless. Now, any variable that's not the independent variable or the dependent variable or like a mediating and moderating variable that's been accounted for in the research design is called an extraneous variable. It's extra to the study. Now, variables that have a direct distorting effect on the results are called confounding variables because they confuse the results. All confounding variables are extraneous, but not all extraneous variables are confounding. In fact, we can't really determine whether an extraneous variable has been confounding until we actually test it, right? Therefore, it's more accurate to say a potentially confounding variable rather than a confounding variable, unless you have evidence or proof that it is actually affecting the results of the study. So to give you another example, let's look at the differences in life expectancy between the people in Oslo, Norway, and Jakarta, Indonesia. I mean, clearly there's a difference if you look up the statistics online. Norwegians live much longer than Indonesians on average. So here are two extraneous variables on which Norwegians and Indonesians differ significantly. The first are poverty levels. Indonesia has much higher rates of poverty than Norway. And the second is hair color. Indonesians tend to have black colored hair, and a lot of Nordic people have more blonde hair. So which one do you think is potentially confounding, and which one do you think is just extraneous? I'll give you a minute to think about it. Okay, time's up. Now, if you answer that poverty levels are much more likely than hair color to have an effect on life expectancy, and therefore poverty is the potentially confounding variable, then you're correct. Unfortunately, you needed to phrase that in the form of a question.
Oh, wait a minute. Oh, dear, Oh, boy, yes, somebody just pointed out to me. I hadn't noticed it. Ooh. You didn't phrase it in the form of a question. I'm sorry about that. We can't accept it. You risk 3201. That leaves you with 1999. And Jeff, you become the new Jeopardy champion. Kathy, I'm so sorry for you. We gotta go. Sorry, sometimes it works that way.
So I once put this Indonesia versus Norway example to a class, and one of the students came back saying that hair and skin pigment could be related to higher susceptibility to certain health issues like skin cancer. She had a background in biology. I obviously don't, so I'm going to trust her on that. The point is that all extraneous variables, no matter how unlikely, remember our aliens, telepathic aliens over in space somewhere beaming messages into your head? Unlikely, right? But never entirely impossible. Any extraneous variable has potential to be confounding in ways that we would never think of. For example, the discovery of penicillin was a total mistake. It was a complete accident. As the story goes, Alexander Fleming was kind of a slob, and one year he decided to go on vacation. He left a bunch of dirty petri dishes and part of a sandwich in his sink to be washed out. So when he got back, obviously, the sandwich had gone all moldy and everything, and the bacteria cultures that had been growing in the petri dishes had just gone totally wild, except where they had come into contact with the mold from the sandwich. So this unlikely extraneous variable, at the time the mold, actually repelled the bacteria. That connection between mold and antibiotics was unexpected, but there's a causal link there. Right? It wasn't something that Fleming or anybody had actually kind of thought about. So the point is, while we're focusing on controlling what we believe are the variables with the highest potential to be confounding, we need to keep in mind that any extraneous variable has at least some small chance of being confounding, and therefore we should work to control as many of them as we possibly can. However, this can present kind of a problem for researchers. Like I said earlier, we're dealing with people, and people are susceptible to contextual influences. In many ways, the most effective way to control variables is to conduct research in a laboratory setting. And in this way, all the participants are studied under the exact same conditions, and researchers have the most control over, the most number of variables in a study. The only problem is that sometimes in order to gain this kind of control, the laboratory environment is so artificial that it doesn't actually resemble anything that anybody's likely to encounter in real life. And therefore, it could actually limit the generalizability of a study. If the results of your study only apply to the people who were actually in your study and not to the population, then your study is not going to be very valuable. While we're talking about validity, it's a good idea not to think of it in terms of a dichotomous binary of either yes or no. It's either invalid or valid. Instead, you might think of it more in terms of a continuum ranging from high validity to low validity. And every study is going to fall somewhere in between on that continuum. Now, a laboratory study like the one we were discussing might have a high internal validity but a low external validity. On the other hand, research that's being done in the field might have a higher external validity, but it comes at the price of a lower internal validity because there's a greater potential for confounding variables. And researchers, when they're doing the research, sometimes they're forced to kind of make a compromise where they're balancing both internal and external validity to reach sort of a middle ground where they find sort of acceptable levels of both. And that depends a lot on what the focus and the needs of the study are. Okay, so let's move on to operationalization. And you'll remember earlier we were talking about content validity, and this is kind of related to that. Very often in educational research, we're attempting to study some pretty abstract concepts or constructs. However, in order for us to conduct quantitatively valid studies, we need to rely on concrete empirical measurements. So I might be able to say, hey, I want to look at student success, but what does student success actually look like? What is happiness? What is love? What is intelligence? Right? What's a family? What does knowledge mean?
How do you know stupidity when you see it?
Well, it's actually fairly difficult to define because you could think, somebody could be doing something, you could say, well, that's stupid, when really it could be ignorant, or somebody could be, just going out of their mind, and you could say, well, that's not really stupid, now they're just crazy. And so it's hard to define.
Stupid? I really don't know. I don't know about that because everybody made mistakes, nobody perfect.
I can't really say what I think is stupid, because that'd be my opinion.
Stupidity is not so cut and dry. For one can be educated and they can at the same time be stupid.
It just can't be defined. I don't know, there really is no definition of stupid, because something could be smart for somebody, but not, stupid for somebody else,
Stupidity to me would be an inability to function in the reality of the world as a whole, Like, I wouldn't, oh shit.
And so it's hard to define. You can't, I don't even know what the definition is, so I really can't say, I can't define it.
People see stupidity everywhere.
Everything is stupid.
But few can define it. People call each other
Idiot.
Imbecile. Moron.
but few know what the words actually mean. When it comes to stupidity, we're actually quite ignorant.
We can go on and on, obviously. Feel a little bit like Socrates. So it's going to be important for researchers to carefully and clearly define what it is that they're measuring as representative of this abstract concept. And this process is called operationalization, or operational definitions. So, for example, if I'm going to measure somebody's happiness, I can't just climb inside their head and, get out my happyometer and evaluate whether or not they're happy. I need something I can actually observe. So, for my study, I might decide to operationalize happiness as the number of times a participant smiles per day. I can count smiles. And basically what I'm saying is that this means that. Smiles mean happiness. And then some of the more contrarian of you will probably point out that many occasions where people smile and they're not actually really happy. Maybe you'll even tell me that it's possible for people to be happy without actually smiling. And then I'd say, all right, smart guy, how would you operationalize happiness? And you'd probably say, well, why don't you just ask people? You could just rate their happiness on a scale of 1 to 10. And then I'd blow a raspberry in your general direction like this and shout, ha! People lie about being happy all the time. You'll never get an accurate picture of happiness that way. Counting smiles is a much more valid way of measuring happiness. Ha ha. Anyway, I don't know why I just became such a big jerk in this scenario. I'm sorry, your idea was good too. Maybe we can do both of them. There's really no right way to measure happiness. Unfortunately, this leads to a lot of bickering between researchers. So, for example, there's a recent debate about intelligence. I mean, sort of recent. It's been going on for about 30 years. But traditionally, intelligence has been sort of a single measurement, the IQ score. Then this guy, Howard Gardner, came along and started saying that in traditional measures of intelligence, we're getting it all wrong. Intelligence is actually a bunch of different domains like spatial intelligence and musical intelligence and interpersonal intelligence, mathematical intelligence, and so forth. And not just a single thing, an IQ score. And according to Gardner, the traditional way of measuring these intelligences systematically marginalizes certain types of intelligence while privileging others. Well, that's a problem, isn't it? On the other hand, according to traditionalists, Gardner's model of multiple intelligences is kind of like giving out participation medals at the Olympics. I mean, it's a nice gesture and all, but if we can't rank people, maybe it's not helpful in making decisions. And there are some other issues with Gardner's model, not the least of which is he seems to have pulled these domains out of thin air. But there may be research being done on that right now to validate some of these different domains. So you can see how operational definitions could generate quite a bit of disagreement within a research field. But the way that we conceptualize a construct is very, very important in research and in policy and in practice, and we often need to, have those kinds of conversations. So here's a fun video, maybe some of you have seen it before, about how a group of medieval researchers operationalized the construct of being a witch.
We have found the witch. May we burn her?
How do you know she is a witch?
She looks like one.
Bring her forward.
I'm not a witch. I'm not a witch.
But you are dressed as one.
They dressed me up like this.
And
And this isn't my nose. It's a false one.
Well,
Well, we did do the nose
the nose?
and the hat, but she's a witch.
Did you dress her up like this?
No!
No!
Yes. Yeah, a bit. She has got a wart.
What makes you think she's a witch? Well, she turned me into a newt. A newt?
We got better.
Burn her anyway!
What? There are ways of telling whether she is a witch.
Are there? What are they telling us?
Tell me, what do you do with witches? And what do you burn apart from witches?
More witches!
Wood. So, why do witches burn?
Because they're made of wood.
Good. So, how do we tell whether she is made of wood?
Build a bridge out of her.
Ah, but can you not also make bridges out of stone?
Oh, yeah.
Cool.
Does a wood sink in water?
No, it floats. It floats. Throw her into the pond.
What also floats in water?
Bread. Apples.
Very small rocks.
Cider. A great gravy. Cherries.
Mud.
Churches. Lead. A duck.
Exactly. So, logically,
If she weighs the same as a duck, she's made of wood.
and therefore...
A witch! A witch!
Very good. We shall use my larger scales.
So let's talk a little bit more about threats to internal validity, and we'll start with history and maturation. These are kind of two linked, related concepts. One of the most common quantitative research designs involves a pre-test and a post-test, right? You give a test, then you introduce some sort of treatment, and then you give another test and you see if there's changes. The test is your dependent variable, and whatever you do in between is your independent variable. However, with this design, you introduce the element of time. There's time between the tests. And when we have time, we have change naturally. We introduce all kinds of other, extraneous variables that most researchers would rather not have to deal with. But too bad they're actually there already. So these extraneous variables are threats to validity called history and maturation effects. Now, maturation refers to changes that occur inside the participant. They may be literally maturing, during the course of the study, developing new perspectives, new abilities, and these kinds of things. Or it could just include some more mundane changes. Over the space of a few hours, they might get hungry. They might get bored with the research. That happens all the time. The mood might change. They might come in happy and then get frustrated or annoyed, So as researchers, we don't want the relationship between the independent and dependent variable to be distorted because, participants became a little sleepy during the middle of our study. So with history, like maturation, we're also talking about changes over time. But these occur outside of the participant and could also affect the results of the study. Again, they could be fairly mundane things. Maybe the participant broke up with their boyfriend or girlfriend. Maybe they finished a difficult assignment, and that changed kind of the state of things. They could also be due to actual historic events, So, for example, let's say you were studying American attitudes towards patriotism. You would have found very different results on September 10th, 2001 and September 12th, 2001, because obviously 9/11 happened on 9/11. And that would have distorted, the feelings that people had towards their country. Now, another threat that needs to be considered by researchers is the effects of testing or measurement or the assessment itself. So let's say I'm doing a study about whether reading these notes actually increases your knowledge of research methods. And I've decided to do this pre-test, post-test design. So I'll give you a quiz in quantitative validity before you read the chapter and any of these notes and things. And then you can come and get all the materials and read everything and study up. And then I'll give you a quiz after we've covered all this material. And then I'll see, if your comprehension has changed. So some of you are thinking probably, yeah, that's really dumb. And you'd be right. By taking the quiz the first time, you'd start learning the material and you'd learn what's on the quiz. So when you took it the second time, I would have to expect you to do better, right? It's not like you're going to do worse the second time around, I would hope. But the test distorts how much you've actually learned from just reading these notes. Okay, another threat we have is instrumentation. And for those of you who skipped chapter 8, I'll just repeat it. The questions that you ask are going to shape the answers that you get. I mean, that's pretty obvious, but it could also be fairly profound. You don't want to have the results be due to some influence of the test or of the question or whatever means of data collection you're using. You want it to be related to the independent variable. When the measurement itself influences how the responses are coming in, then that threatens the validity of your study. So you need to be careful that the questions that you're asking or the instrument you're using to collect your data isn't significantly distorting the results of the study. Sometimes that can be solved by asking multiple questions or taking multiple assessments of the same construct in different forms. Okay, so regression artifacts. Now this one actually involves a little bit of statistics. I'll try and keep it fairly accessible. In most things we measure, we expect what's called a normal distribution, which is graphed as a normal curve, or they also call it a bell curve because of the shape of it is a bell. Now the mean or the average of the bell curve is going to be 50%, and that falls right directly in the middle of the curve. And that means that half of the individuals that we test are going to score higher than that value, higher than 50%, and half are going to score lower, obviously. Now, as you see, the further away you get from the mean, from the average, the fewer individuals are going to be represented. In fact, what you see are these different sections. They're known as standard deviations. And, according to the statistics, right, 68% of the population is going to fall within one standard deviation from the mean. 95% will be within 2 standard deviations for the mean. And that leaves just that 5% out there on the extreme ends, right, within 3 standard deviations. And so as you go further from the middle, you have fewer and fewer people represented. And that means that most people are roughly average. So let's say we're doing a study about test performance in a geography class, and our class falls into this pattern. Test was pretty hard. So most people score somewhere between 42 to 68% on this test, right? And that's fine with us as educators. But what we want to look at is the extremely low performers out there in that 3rd standard deviation. Now, if you're looking at the graph, you'll see that the shape of the 3rd standard deviation, that bit in orange, is different from the shape of the overall, bell curve. And if you were to take just the people in that standard deviation and then divide them down the middle, you'd actually see that there were more people on the right side of the deviation than the left side. Whereas in a normal curve, you remember both sides were equal. And of the few people that are contained within this section of the bell curve, the third standard deviation below the mean, you would expect that some of them are there because that's what their true ability is in geography. They don't know any of the state capitals or, any of the state names or anything. They lack the ability to score any higher than what they got. On the other hand, you might have some people who are there because they just had a bad day or they didn't get much sleep the night before or whatever reason, That's not necessarily a reflection of their true ability in geography. So remember, we always have some kind of error in our tests. Measurement equals truth plus or minus error. So if we were to give another test in geography, the people whose true ability is in that third standard deviation below the mean are going to stay where they are, but we'd expect to see an increase in that group. It would be very unlikely for that group to decrease. There's not really that much room for them to decrease too. There's far more room for improvement. So either they're going to stay the same. If they decrease, they can't decrease that much, or they're going to increase and move towards the mean. Given enough time and enough chances, enough measurements, people tend to move towards being normal or towards being average rather than away from it. And so that's what regression towards the mean means. And then the final threat is differential selection or differential attrition. So we talked a little bit about random assignment, and we're going to come back to it again in the next chapter. But random assignment uses probability to create balanced groups. And usually that works out pretty well, but because we're using probability, there's always a chance that one characteristic is going to end up stacked up in one group. And in your text, there's table 11.1, and that'll give you a list, not an exhaustive list, but a pretty good list of what those characteristics might be. Now, if you're using non-random assignment, then you're actually likely to increase the chance that groups are going to be unbalanced rather than decrease it. And so, like in sports, with assignment, you want it to be a kind of a fair matchup. Attrition, on the other hand, refers to people dropping out of your study. For example, if you divide your participants into a control group and a treatment group, and the treatment is so awful that half of the participants in that group, quit the study, that's going to unbalance the groups, right? And that'll cause distortions in the result of your research. Similarly, you might find that different groups might mature differently or have different history effects and things like that. So you have to watch the groups and be careful about, that the different variables are affecting them equally. Okay, so we talked about generalizability when we talked about the selection process, so I'm not going to go over that again. But the other name for generalizability is external validity. How well do your results represent the population? So let's skip ahead a little bit and we'll talk about statistical validity. Now you can break this down into two things that you're going to be looking for in a results section. The first is statistical significance, and the second is effect size. Now, statistical significance refers to the confidence that researchers have that their results actually represent what's happening in the population. So if you remember the normal distribution that we were looking at earlier, I guess I'll put up the graphic again. Test scores will fall into this kind of distribution, but so will research results. Theoretically speaking, if we were to repeat the exact same experiment 100 times, we'd find that the results sort of fall into this pattern. The majority of the results would fall around an average, right, or a mean. But because of the effects of random chance or error, you might end up with a study or two that produces sort of more extreme results. So statistical significance in a research study, because we're not going to do the same experiment 100 times, says that probably chance did not affect the results. If we were to theoretically repeat this study, 100 times, we'd probably find results that are similar in at least 95% of those studies. Or 99%, or 99.9%, depending on what our significance level is that we're willing to accept. Typically, in social science research, we're willing to accept a 5% chance that our study results may be due to error. Now, on the flip side of that, we have the effect size of a result, or the practical significance, sometimes it's called. In other words, how much of an effect did the independent variable have on the dependent variable? Now, effect size and statistical significance are kind of related, but they're not the same thing. If you have a bigger effect size in your results, then the probability of it being due to random chance is smaller. But you can have a statistically significant result that has actually a minimal effect size. Sometimes this happens in the media, they're reported all the time, the statistical significance of a study instead of the effect size of a study. So to give you an example, there were some pretty large studies done, I guess back in the 90s, comparing math achievement between boys and girls. And the results of these studies found that there's a statistically significant difference between boys and girls in math. And all that meant, really, was that researchers who were doing the research were very confident that some difference existed. Well, the media picked this up, and they got really excited because there were statistically significant results, and they started reporting, well, girls can't do math and we need to help them catch up to the boys and so on. And it actually influenced some of the educational policy at the time. Well, on closer inspection of the studies themselves, the actual difference between the girls and boys were very minimal. I mean, they were negligible. The difference was pretty much meaningless. And where they did find sort of larger differences, other studies were able to go in there and explain those differences away as being due to, some confounding variables like the socialization of girls versus boys, or career expectancy. So as it turned out, even though the results of the study were highly statistically significant, gender in itself was not related to math in a meaningful way, especially when all else was held equal. So those are some of the issues you're going to want to look at in the validity of a study, and those are good to look at when you're doing the research. They're also really good to understand in terms of reading and reviewing, critically research studies that are out there that are going to inform your practice.